and temperature.
I think we're live. Hi, everybody.
Hi.
I'm just making sure that it's everything.
It's a little off the overview of the
So, hi, everybody. It's Maggie and Patrick from A1DesignBuild. And tonight we are going to talk about high performance building. And we have questions prepared that we're going to be doing a little improv, and because we've been so busy, we didn't actually get to study these, so we have to go off from our knowledge. Like if we were to show up at your house and talk to you about high performance building, this is the kind of stuff we would say.
This is what we talk about.
Yeah. So
can people ask questions?
They can. And
maybe it's a bit presumptuous to think that anyone would actually be here, just in case.
No, people will show up.
Yeah.
So Chris Donaldson is in the background here. You can't see him. He and the dog, Nar.
The Nar.
The Nar is here.
I'm laying next to the dog.
Oh, they're laying up front there. Anyway, he can keep track. I think if we have a question pop up, he'll probably tell us. And we can definitely answer questions as they come along. And we'll keep it says finish here. Are you sure we're live, Chris?
I see it.
Okay. What is the finish is to end it.
Yeah.
Yeah. I'm not super savvy at this, so.
You've just started.
Okay. So you want to start with the first biggie, the big one?
Question. It's the big one.
What is a high performance home? Do you want me to
Are you going to go first? Are you going to lay down the baseline and then I'm going to work on top of it, or is it vice versa?
I think I can, because I manage the design.
She's the designer. She should know these things.
So a high performance home is going to be a home that is comfortable, durable, energy efficient, and I know what you're going to say. I'm not going to say it because I know you're going to say it. But it also makes you happy to be in the home, healthy. So, you want to add to that?
So it's healthy in the home.
Yeah.
Yeah. I was going to say, it's simple, which means that it's easy to take care of.
Oh yeah.
And it lasts a really long time. And it's comfortable, and it's safe, and it's healthy, and it requires as little resources as possible from outside of itself to operate, which is especially important in our day today, because we're using resources that are oftentimes coming from other parts of the country or the world or the state that we're using for our benefit. So that seems important. And also, we're making a simple machine. That is also simple to operate.
Yeah, it is. A house is kind of like a machine. And I would say that you would think, all right, well, that's any house, right? Any house is comfortable, durable, easy to take care of. No, it's not. Energy efficient. And I would say, no, it's not. And even a recently built house is not necessarily all of those things.
Criminal. Absolutely criminal.
I don't go there, but I would say that they can be lacking definitely in their efficiency because maybe something wasn't installed properly. The good news is that Washington State Energy Code is requiring builders be way more efficient in how they put their assemblies together, and it's just only going to get better over the next 10 years. It's going to get more stringent. So I'd say that's a good thing, but if it's not installed right, it will fail. For instance, if you're depending on your air barrier to help keep your envelope working properly and somebody doesn't install it right, now you've got leaks and it's air washing the insulation and the insulation can't do its job.
We'll talk about air washing of insulation shortly.
Yeah. Okay.
It's a subject that deserves its own live event all by itself.
Yeah, air washing. So I'm going to keep my eye. We want to get through how many questions in an hour? We've got 1, 2, 3, 4. I think we have 10.
10, Chris?
4.
There's 8.
8.
Oh. 5, 6, 7. Yeah, 7 or 8, somewhere like that. So we can go a little bit longer on this one question if we want to.
7.5 minutes.
Okay, so the thing that Chris pointed out that Mike Feeney said in a recent blog post.
Yep.
Where the architect on staff here was asked, what is your definition of a high performance home? And he said a lot of this, of course, but he also said it's where you're happy. So that's sort of interesting. What is it that makes you happy in your home? Is it the comfort? Is it feeling like what you purchased was good for the planet? What is it?
Got a good value.
Yeah. Or is it like that you have a really big TV and good speakers
and a hot tub to watch it from?
Yeah. That's all part of it too. That makes people happy. But installing all of those things or having the blocking in the wall, it's all part of a high performance home that it's done well.
I'm going to point out something that Maggie has said often in the past and continues to say so. And that is that a house that's built to be beautiful is most frequently a house that's taken care of. Mm-hmm. So a house that someone finds is comfortable and safe and they like to go home to, they're likely to take care of it for a longer period of time, mm-hmm. which is good because that means it doesn't end up in a hole in the ground or in someone's oven when they're tired of it.
Yeah.
It lasts longer. That's an important part of a high-performance home from a sort of resource use point of view.
Right.
But I think we're going to get kind of techie in a second here.
Oh, with the other questions? Yeah, for sure. Yeah, there's some really cool things about high-performance home that I love talking about. Mm-hmm. Oh, let's see. What is it? What are some of the you ready for me to go?
I think we should jump into the big question because everything else sort of falls underneath that question.
Stay on this one for a minute. Well, okay, so
everything else
if I was going to define like the systems of a high performance home, I would say that everything is based on electric energy. And so you've got a heat pump to heat the air in the house. You've got a heat pump if you're not heating the air, you're heating a hydronic system. They're now making those. That's recently something that we've seen.
Using the same technology as
heat pump. Yeah. A hydronic used to not be available with heat pump, but it is now. And you can also have that hydronic go into old fashioned radiators underneath the window, like you would see around
like Chris has in his house probably.
Yeah. And okay, so you'd have a heat pump to heat the air or make you comfortable, and also to heat your water. You'll have a heat pump for that. You also have a heat pump to dry your clothes. Your kitchen appliances will be Energy Star rated, including your stove, which would be induction range. Yeah. I almost totally blew that.
She was so close to the edge right there.
Induction range, or stovetop and cooktop. Mm-hmm. And there are some, there's a couple of appliances you cannot get in Energy Star. And one of them normally is a dryer. But if you get a heat pump dryer, I think that is about the only type of appliance dryer that is Energy Star rated. Yeah.
So you're really talking about mechanical systems.
Yeah.
And so on that list that we just talked about in terms of the kind of resources that the building is using, mm-hmm. then the stuff inside that's using resources, namely electricity or gas, whatever, is really important. You're sort of pointing to those things.
Yeah. The one, I just wrote it down because I didn't want to forget. The other appliance or mechanical system that is really important to a high performance house, if you're building a new one, is an HRV, a heat recovery ventilator. In our area, that's what you would use. If you were living in the South, you would get an ERV, which is an energy recovery ventilator. So it's not a system to heat your house, even though the word heat is in it. It's a heat recovery ventilator. So you're taking you're taking polluted air out of your house and you're bringing fresh air in your house. But when you, as the warm polluted air passes out of the house and the fresh air comes in, there is a heat recovery ventilator. It's a little machine, and it doesn't mix the air. It doesn't mix the air, but the air does pass through chambers next to each other, and the heat is extracted from the air that is leaving the building, and it's transferred over to the air that's coming in the building. Yes, it's magic. That's as far as I'm going to go on the explanation.
David Copperfield.
So heat recovery ventilator is really, really important to a high performance house because of the health issues.
So you're taking off the healthy box.
Yeah. It's got a filter in it up to I would recommend up to a MERV 13 will take care of any allergens that could come in. It takes care of smoke. They're quite amazing at keeping your home full of fresh air without opening all the doors and windows, because you can't do that all the time. There's times of the year where it's just too cold to do that. So
that's the healthy and safe part of a high performance list. We were just talking about the energy efficient or low resource use when we're talking about the quality of the components inside of the building.
Mm-hmm.
And now we're going to talk about, we talked about the make you happy thing.
Mm-hmm.
And then, so we've got this whole question of sort of durability and long lasting sort of thing. But let's save that until we talk more about the building envelope and why that's important.
Okay, yeah. That question is next up, is how do you define the building envelope? And we have have differing. Okay, I'm in the design department. He's in the sales department. Well, he also is a carpenter. He builds, and he was a designer. I'm just teasing him. He wears all the hats. So I define an envelope as basically everything to do with the exterior of the building, the very exterior of the building. So it's going to take in the roofing, the siding or cladding or stucco, whatever you have on the side of your walls. It's going to take in all the windows and doors, the fenestration, and then all of the gaps between those things are part of your envelope, and you don't want gaps. So you want to have those all sealed. And then you're also going to wrap that down to your foundation, whatever that assembly is. You're going to continue that envelope. And think of an envelope, a sealed envelope,
Like a balloon.
Like a balloon. Yeah.
It's a balloon.
It is. It's like a balloon. You make a balloon for your building. And then by using the heat recovery ventilator in there, you can have a super airtight house, and you don't have to worry about asthma and allergens and things because you've got fresh air constantly circulating through the house.
So someone asked a question, how do you measure the efficiency of the envelope? But before we answer that question.
Oh, someone did.
There's another way to think about the envelope of a building. It's the shell of the building. It's the exterior surfaces. What's underneath, what's around, what's on top. But another way that we think about this is, because we've worked on thousands and thousands of buildings in Whatcom County, and we see commonly repeated mistakes and failures that have led to other more significant structural damage or other health concerns. But basically, I rate houses on this continuum, and on the left side of the continuum is a soggy paper bag. We've all probably lived in a soggy paper bag at some point in our life and called it a house. And on the other end of the spectrum is really what we want to build, which is really like the best cooler you have ever used. So you put one can of cold beer in there, and all of the other cans of cold beer get cold and stay cold for days and days and days and days without introducing any additional energy to change the temperature. So in an ideal world, we're building envelopes that are airtight and hyper-insulated. Airtight, watertight, and hyper-insulated. And so it takes very, very little energy / resources to affect the indoor temperature of that building. So it takes as little energy as possible to raise it up to a comfortable level. And that comfortable level stays that way for as long as possible before we have to introduce any additional energy to change that temperature back to the comfortable level.
Mm-hmm.
And so that's how I think about a building envelope, is how do we make the shell of a building like a thermos, basically.
Mm-hmm.
And so when we're talking with clients, sometimes we can get super geeky in terms of, how do we build it? Is it made out of wood? Is it made out of bricks? Is it made out of concrete? Is it made out of foam? What are all the components of that? I don't think we're not going to go into that. Are we going to go into that? You sort of touched on that with the building wrap.
Some material stuff.
The building wrap
will.
thing. Yeah.
But we missed sort of a really big one on the overall definition, because we get fixated a lot of times on the building, the structure itself. I mean, just roof, walls, and foundation. But integrating that with the site is super, and the sun is super important.
Yeah.
And so that is also a big part, how you orient the roof, what kind of pitch you have, how much attic space are you building that is not going to be used at all, how high so.
But the nature of the envelope from a performance point of view, whether it's a box or a cylinder or a circle or a pointy thing,
Mm-hmm.
It doesn't really matter. It's the nature, the thermal quality of that envelope and the ability to keep out the weather and to keep in the energy you've used to cool or heat that building is critical when you start asking the question about the resources that it's using. Because if you don't build a house like that, solar panels are not going to add very much.
Mm-hmm.
Putting solar panels on a 1914 Victorian in Bellingham, Washington are going to do nothing but give money to the people that put the solar panels on your house. If the house is not addressed, if the thermal quality of the house, the envelope is not addressed in that house, those panels will not perform to expectation. But it also applies to the things inside that house that are using energy. So all of that stuff has to be thought together. It has to be thought of as a integrated system and be thought of together when you're either designing a new one or when you're changing it. Mm-hmm. So the envelope is not so important as the relationship that the envelope has to all of these other components: comfort, sustainability, energy use, durability. All of those things have to be taken into consideration when you're trying to answer the question, what's the best envelope for my house?
Mm-hmm. Right. And so the one that I said that was orientation doesn't really apply to that if you're just working with an existing house, which is a great idea. If you have a house and you want to do an energy retrofit to it, turn it into a high performing house, even though it's older, I am your cheerleader. I think you should do that. You don't have the choices on roof for getting solar the way you do when you're building from scratch. So I think that this one is a good question. What are some of the materials most closely associated with high performance homes? Okay, I would say first off, triple pane windows or very a very low number on your U factor for your windows.
Can you talk more about what that means to the normal?
Yeah, a U factor is sort of the inverse of an R factor.
That's not actually as helpful as it just sounded.
I know it's a calculation that we do that measures how much resistance to heat passing through it the window has.
Good one, right? So it's a way to measure the efficiency of a window.
Right, and they measure the glass, they measure the frame, they measure, like, they get down to measuring, like, there's actually this little bit of resistance that happens on the surface of the glass. Like, it's a super geekery thing that they do to come up with these numbers, and every window company has to have their window, rated for a U factor. And in our area, a U factor of 0.30 is code compliant. But if you want to have a high performance house, you want to go down to 0.22, down as low as like 0.16. you really want to get lower. And windows, I would say windows having that U factor number. High performance would be very durable siding that's easy to take care of, and that could be
a really long time.
Yeah.
Keeps out the weather.
It could be metal. It could be hardy board, cement board. It could be stucco. It could be wood, but it's also going to require more maintenance.
Could be concrete.
Yeah, it could be concrete. It could be plaster on straw bale.
Plaster on ICF construction.
Or ICF or Foswell.
Straw bale.
Which is not straw bale.
Now we're talking about envelopes.
Yeah. Okay, so the wall material, often what's associated with a high performance wall would not be just stopping at the insulation, but the continuous, not stopping at the cladding or the siding, but that layer right below it, which is the continuous insulation that's keeping the building warm and breaking all the thermal bridging that's happening. So those two come to mind right away. Do you want to add some more? Because I can keep going.
Okay. Well, I was just going to say that Maggie mentioned the word thermal bridging, which is the thing you're trying to avoid. So when you're building an envelope, a high-performance envelope, remember, we're trying to build a cooler. We want to keep the heat in as long as we possibly can. And so in conventional houses, and you can see this in your neighborhood, get up early tomorrow morning, drive around. I guarantee you'll see it on half the houses in your neighborhood, which is you'll be able to see the wall cavities and the studs. On a cold day, the studs that are used to build that wall, if there's not a thermal bridge, they are highways of thermal energy from your living room that is sending the thermal energy through the stud to the outside and melting the frost on the siding.
Yeah.
Which is why there's a discoloration on buildings. And on a cold morning, you can drive around Bellingham, you can see it on roofs, you can see it on walls. And so this idea of thermal bridging and trying to stop that, a part of that kind of envelope is that we're resisting the thermal transfer from the inside to the outside as long as possible, using as little resources as possible. And an easy way to do that is to insulate the exterior of the building. It's protected by the cladding, but it's stopping the thermal energy from exiting the building via the pathway, the grand highway of the wall studs.
Right.
We want to stop that.
And there are some other things that can cause thermal bridging too. Sometimes when you attach a deck to the side of a house, you'll have a big old ledger board, or there's an exterior porch roof that's attached to you often can create a thermal bridge through adding those things on. And so paying attention to how we can break the thermal bridge. So you don't want bridges, you want to break the bridges. We pay attention to that when we're building things.
Another thing that would be counterintuitive is the very windows that you're trying to put in that are also resisting the transfer of thermal energy. The frame of every window in your house, if it is not insulated, it is a grand highway for thermal energy to leave, not through the gaps because someone installed it in too big of a hole and didn't seal it, but the actual frame of your window is transferring thermal energy.
I'm going to just get up and grab a sample. And
Maggie's going to get a sample. This is exciting.
So this is cool because our showroom, in every drawer and in every cubby, we have stuff for you to look at.
We have so many drawer pulls.
We have a lot of fun stuff, tiles and drawer pulls and things like that. But we also have this kind of thing right here. Let me find one that's got insulation. This one. And I don't know that it's got all the insulation in it, but it shows you.
But it's what we're talking about.
The idea. So this is a window that has been.
Yeah, this is a cross section of a fiberglass or vinyl window. Vinyl, I think.
This one is vinyl. So there's a piece of insulation there, and there's a piece of insulation there. And so that's breaking that cold. So I always have to look at this and say, where's the inside? Where's the outside? This is the inside. Because they don't.
That's the outside.
It's really hard to tell when you first look, at these because they don't have the nail fin on. Oh, that's the outside. Yeah, this is the outside. This is the inside. Whoops.
Yep.
And so one of the things that happens is that if there's no insulation in here, you have these empty cavities basically, and the cold can pass through there. There's nothing stopping it from passing through and making the inside of your window cold. And if any of you have old aluminum windows in your house, you'll really...
Or wood windows even.
Wood windows too. You'll really feel that.
Like in an old house, they have like traditional sashes, like wood frames, and you lift them up. They've got the weights in inside the walls, and they're from like the 20s or 30s or 40s or 10s or 9s. Those are wood. They're solid wood from the inside to the outside.
Okay,
and so that's just another example of a thermal bridge we're trying to stop.
That window was a Pella, and I don't think all of the insulation was in all the cavities. Here is a Cascadia from
Super
this
whammy.
is a Canadian window, and it's got the insulation all the way through all of it.
So those people, especially in northern Canada, they're super concerned with high performance building. Us Americans, we're United Statesians, we're a little bit behind the curve sometimes. It takes us a while to catch up to common sense. So windows, cladding,
roof. So I would say for a high performance roof, a metal is going to be, in our region, is probably going to be the best choice for a high performance roof. The next best would be like a triple laminate asphalt roof. What's kind of cool about the metal roof is I feel good about collecting water off from a metal roof. If I'm going to put it on my garden, I feel better about that than collecting it off from an asphalt roof, but that's not the end of the world. You can filter it. And, so we've got the roof, we've got the cladding we talked about, the windows, and then the doors. So I was surprised when we installed a passive door, which is... Passive house is a super high, it's like the highest standard that you can meet for energy efficiency, among other things. And so we put on a house here in Bellingham, we put some passive doors on them. And
passive house rated.
House rated.
It's a type of rating about the quality of the performance of the building, and products can be rated in a similar manner. And then that, as a designer, that helps us know what components are going to help us get a certification that tells us that this house is passive house certified, which may not be important to you. It's kind of important to us, but for some clients, it's really important to them. If having a high performance building is really, really important to them, then it can be in their best interest to have us design it in that manner, because it requires us to have third-party verification. So it's not just us saying, no, we did a good, we did a good job. And it's not just the code compliant people, the municipal officials that are saying, no, they built it to code, because code is far below what a high performance building would be. It's literally the least that you can do, although it's changing somewhat. So this whole sort of certification, the Energy Star thing that you mentioned, the passive house certification, there's a variety of certifications that help guide designers and builders to build within certain parameters that ensure a really high quality, high performance home. And sometimes we use that information to guide our efforts when we're working with clients that are trying to meet those standards, or we're just trying to build something that we feel really good about, and it helps us have a clear path forward and know that we're building it to a standard that can be appreciated and acknowledged by someone other than us.
Yeah, and what does it say about those passive doors, the passive rated doors, and then same with the windows, is when there's a weight to them, and there's a friction fit when they close. They're like
it's like the space shuttle.
Yeah, it's quite nice. Now, having said that, we're really talking super high performance here when we say passive. And of course, we would love it to build a passive house for anyone, but also we're all educated to that level, and so we're constantly applying that knowledge to regular buildings. Like, how could we bring this back door up to a better? And if we're not going to put a passive door in there, but what is it that we want to do with the windows, for instance? We're not going to put passive windows in there, but we're going to put good windows in there. What's the best window? A friction fit window, which is an awning, a casement, something you crank shut, will give you, or a hopper window, which is the top pops in,
or
or what?
Or out.
Or out. Those are friction fit windows as compared to a slider is not a friction fit, and or a single hung or double hung, and those will they'll adjust over time, expand, contract, etc., and they can get leaks and they can get a little bit loose, so they're not quite as good as the friction fit windows. So if you're going to choose what type of window for the most energy efficient, I would go with a triple pane that's friction fit or a double pane that's friction fit with a good U number.
French door that swings in, that swings out.
Yeah.
So when the weather blows against it, it closes it tight against weather stripping. That's another example. But before we jump into that, I just want to answer Chris's question a little bit here about the efficiency of the envelope, because we can talk about all this and we can show you credentials. But in the end, and this is oftentimes required of us by third-party verifiers or even city or municipal officials, how do you actually measure that a house is built well or that the envelope is actually efficient? So there's a number of tools that we use, and we typically measure the efficiency of a building when we're going to make a significant impact on an existing building, like we're going to do an addition, we're going to do a huge whole house remodel, got the whole thing and put it all back together, put a second story on it. When we're really significantly affecting the envelope of building, we want to test it first to see how well it rates. And then we want to test it as we go along to make sure that we're doing all of the steps we need to do to really button that building up and have that envelope start approaching a thermos or a cooler. And then we test it at the end. And sometimes in certain situations, we're required to do that to get a certification or sometimes even to get a permit signed off on. And so there's a variety of metrics that are used to measure the efficiency of an envelope. And there's a couple tools that we use to describe that to clients and test that. One of them, which you may be familiar with, is a blower door test. And we're basically depressurizing or pressurizing the house. And then we're counting how many air changes happen when we're pressurizing that house. We're basically blowing up a balloon in order to find out how many leaks there are in that balloon and where they are, so we can eventually stop those things. It tells us how much air and thus thermal energy is leaving that building. So those are some tests we do at the beginning. We also find thermal imaging pretty handy, especially when we're doing repair work. We have a thermal imaging camera that allows us to walk around your house and identify all of the spots that don't have adequate insulation, that are leaking air, or that are allowing moisture to penetrate your building. And those are tests that we can do as we're building a building. And in fact, it's much more likely that we can achieve the results if we're testing the envelope as we're building it and as we start to enclose it, from the inside and the outside with drywall and siding, right? We want to be testing these areas while we still have access to them to fix them. And so those are tools that we have that we use a lot on most jobs, and they're oftentimes required in order to meet the standards that we're trying to meet, especially if they're dictated from outside of our firm.
Okay. Do we want another question? Let's see. Oh, one more thing on materials, I would say. So if we go to the inside of the house, the fact that you would have healthy materials in there that don't off-gas.
Yeah.
And there's all sorts of standards that products can meet to prove that they're not going to off-gas. They're not going to put chemicals into the air. And we sort of curate our showroom for those type of products. We don't have every product. You can go to other showrooms in Bellingham and in Seattle, and you'll find more products than we have in our showroom. And part of that is that we are curating and keeping some products out of our showroom because they are not as healthy as the products that we like to put in all homes, not just high performance homes. So I would say the materials that you're going to be living with and touching and crawling around on the floor, they have to be healthy. They have to be good to touch. They have to be good for your body.
Yeah. And one of the
natural materials.
This is not tested
awesome.
by me, but I suspect this is true. And there's actually quite a body of work that points to this in dietary conversations as well as in material conversations, which is generally, I wanted to swear a lot. It's a whole bunch of words right in a row, but I'm not going to do that. But generally, the less most of you will agree, I think this is pretty well established, the less processed the food is that we eat, generally the better it is for us. We will generally live a longer, happier life if more of the food that we eat is more closely linked to its original state, right? Potato chips are not as healthy as potatoes because they've gone through a whole bunch of things. We remove nutrients. And a general, God damn it. Oh my God. So another way to think about this is if the materials and the more processed, the more chemicals, the more steps that we go through to render a material suitable for a building, especially inside, not as much outside, but especially inside, those materials tend to have more problematic effects for the residents and the people who make them, right? So a wood window is more of a natural product than a PVC vinyl window. And we can demonstrate that. We actually have air quality testers that we put into buildings that we're working on, and we can measure the volatile organic compounds. See, Adriana loves it when I swear. I knew there was someone out there. But I just think if you're just like wondering what kind of stuff can I put in my house that would just be healthier? In general, the more natural it is, the more closer it is to its original state, the better it is for you. Here's a really great example. There's recent studies that indicate that a wood cutting board is one of the best surfaces for cutting food on, right?
I have had this discussion with so many people.
And there's a recent study, because we like to put pretty oil on wood because we're wood people, right? And I'm realizing that the act of adding that chemical to the wood actually makes it so that it will retain bacteria for a longer period of time. And so every time when we paint things, we're introducing toxic chemicals to our world. Carpeting is a highly nylon carpeting, plastic nylon is a highly processed material, and it will introduce volatile organic compounds, VOCs, into your living space for an extended period of time. So how natural are the materials? That's a good question. We really want to try to incorporate more and more natural materials in the buildings that we're doing. And it's something that I want to do. I try to do in my own house as well. It's challenging because most materials for building are highly processed.
Okay. So I'm going to put that one aside, the materials, and then...
That's part of the healthy and safe checkbox on the high performance home list.
Yeah, okay.
Yeah.
Yes.
Oh, that's a great question.
Do you want to talk about that one? Do high performance homes cost more? Is it worth it?
Absolutely.
I wrote my answer
and
down.
Absolutely. Yes and yes.
Well,
that is all.
My answer is different because I'm like, I say, how long are you measuring as far as money? Because you're going to have payback for a high performance home. You're going to have less maintenance costs. You're going to have less energy costs.
Yeah. More upfront cost.
But more upfront costs. So it's going to balance out those upfront costs.
Your return is going to be quicker.
But in general, it's going to cost more to build a high performance house than it is.
But that's if you're just being a selfish individual who doesn't care about anyone else.
Right.
You only care about how much money you're going to save and how much you get for your money.
Yeah.
But a high performance house that uses these materials in what I consider a more responsible manner extends to a larger part of our world. We all know there's lots of studies that indicate that the primary cause of our climatic issues right now is the built environment. Residential and commercial. And it's not just the production of the materials and shipping those materials all over the world. That's problematic. It is the operation of those buildings. It is the resource use that is causing, in a large part, up to 40 to 50%
Yeah.
of
And-
greenhouse gases originate from the built
Yes.
environment
That's
operating.
really true. Yeah, it is true.
And so our choices about what kind of building we build, while it might be a small drop in a very big ocean, is still a drop, which is better than no drop at all.
It is. The other thing is, and this kind of goes into another question here, but do you remember that old video, The Story of Stuff? Do you remember The Story of Stuff? Like, The Story of Stuff still applies, because when you buy things that are cheap, it doesn't cost you very much, but it does cost the environment, or it costs another population that had to work for a very, very low amount of money to make the thing, or it costs the extra energy to ship it all the way across the world. It just,
there are still
even though it was cheaper, there's expenses. That's what I'm trying to say, is there's expenses. You're taking, when you buy something cheap, you're pushing your expense onto the rest of the world.
We won't hold you responsible. When Maggie and I buy cheap shit, which we do all the time, because it's absolutely compelling to do so.
I don't think so.
What's that? You just got an Amazon package. It's literally sitting right there. I guarantee she ordered that like 9 hours ago. They dropped it off of the truck.
No, I'm not. No.
That's made out of plastic.
Patrick, you're projecting now.
I just wanted to take our viewers off the hook and not
everybody that knows.
We're not judging you. We're judging ourselves. I'm judging Maggie.
Yeah, no, I know. I did get a little preachy there. I'm sorry. I didn't mean to do that.
But I think the point is that the choices that we make on the materials that we use to build a home have an impact on what we would consider a high-performance home. And for us, a high-performance home has to do with where and how the materials we use were produced. Mm-hmm. I'm gonna go right to the cliff's edge right now and just say this thing. The argument about sustainability, total bullshit.
Oh, he loves saying that.
We are not a sustainable...
Especially since we just are in the process of getting 4 more sustainable home professional certifications
it's all
for our
lies.
design department.
Everyone, it's all lies.
No, oh, God.
It's all lies in misdirection.
No.
There's nothing we do when there's that many people that need a place to live.
Yeah.
There's nothing we can do at our current rate to be sustainable. There simply is not enough stuff for all of us. And so I have a hard time using that word in relationship to what it means for us to do the work that we want to do. Mm-hmm. But here's where it is different. If we have a limited amount of stuff, we have a responsibility to be very careful with how we use that stuff. Mm-hmm. And we can do that. And you can do that when you make choices about your house. And the idea of a high-performance home is just a pathway to help make a better decision about what it means to be a good steward of a limited set of resources. Yeah. Which is feel free to argue with that, but I don't think you have a leg to stand on.
So are we going to, not that he doesn't have judgment on that. No. So yes, we are getting 4 more sustainable home, or we're going to have 4 people with sustainable home professional certifications from Earth Advantage. And yet we don't believe that sustainability is really a quality of the built environment right now.
It's being used like,
but if we don't study these things in the light of sustainable home building that is out there now, the knowledge is out there now, the building science that's out there now, we'll never get there. So it's contradictory.
It's a good exercise.
But we're not trying to fool anybody.
No. It's problematic. Most of you remember and maybe even use the new word about greenwashing, like green building. Like, at some point in our world, that was like, we don't even know what you're talking about anymore. The word's absolutely meaningless. And I just feel similarly about the word sustainable.
Right.
It's something we can throw around there, but it doesn't have a lot of like meat to it. Mm-hmm. But we can be careful with our choices.
Yeah.
We can actually do that, and we can demonstrate that too.
So we're at 4. Oh, I want to do this one. We're not going to get to all of them as usual because we just start talking and we don't stop.
All right, we got that one.
This one,
cost more and worth it. Yes.
Yeah,
yes and yes.
We got that one. Any new technologies or innovations we should know about? I think so.
Yeah, there's some pretty cool things out
And
there.
I think that I want to talk about this one, and you should talk about those two.
Copy that.
Okay, so I'll be quick. I mentioned it earlier. I'm not sure that I'm a fan about this, but it's a new technology for people who really love hydronic heat. You can now do it with a heat pump. I mentioned that at the beginning of the talk, and I just want to mention that. Kurt Walden.
Oh, hey, Kurt.
Hi, Kurt. I agree. If I may get preachy for a moment. Healthy homes, airtight, with dedicated HRV, with good filters, etc. Hold on.
Oh, Maggie, does it not work?
It doesn't. I'm pressing the see more button. Can you read it, Chris?
Kurt Waldenberg.
Oh, there. I got it. It just opened up. It took forever. With dedicated HRV, with good filters, etc. Long-term, better for everyone. And he gives a little prayer sign.
Nice one,
thank
Kurt.
you sign. Yes, agree.
Yeah.
Okay, so any new technologies or innovations we should know about? The hydronic heat pump for people who want to that heat in their floor system or in their radiators. So yes, that's new. And then
that's interesting because we've defined that heat pump heaters, right? The technology of those compressors that are using refrigerant to heat and cool our homes with heat pumps, or some people call them mini splits. That same technology is starting to get applied to other forms of heating. And in this case, we're using hot water to heat our floors and our radiators. And Meg is going to point out some other ways in which that heat pump technology is being applied to potable domestic water.
Yeah, to hot water.
Drying our clothes.
Right. Those are the three.
Those are like the four.
Yeah, the air, the water, and the clothing.
The clothing.
So the other thing that I want to cover really quick, and then I'm going to give it to Patrick, is the Aware, which is we started measuring our buildings, and we do it in a variety of ways. But one of the really cool ways is to get a little Aware reader. It's AWAIR. You can look it up online. You can just pick one up for it's under $200. I think it might be $150 for an Aware. And you plug it in and you hook it up to your phone, and it measures in the area of that room. So I'd put it in like a great room or a bedroom that you're concerned about, for instance. What's the air quality in here? It will measure humidity, temperature, particulate matter, and CO2.
And VOCs.
And VOCs, yeah, it measures 5 things. And
all of which are really bad for you.
And I used to think, oh my gosh, I was comparing our office here, because we had one here, to the high performance house that we built on Cable Street. And I was looking at the numbers on both of them. And I'm like, oh, the high performance house is so much better than the office that we're in. And we need to improve our office, right? And I was whining about that often.
Yeah,
and then I bought an Aware for my own house, and the office is better than my own little condo.
Yeah.
With just me living in it. Terrible.
It's a toxic
it's actually super airtight. I have to open the windows all the time because I don't have an HRV. Okay. And then you're going to talk about these two.
Yeah, and we use the Awares. We actually put them on job sites when we're working on job sites, and it helps our team be aware that they're not creating an unsafe environment for themselves or an unsafe environment for our clients who may or may not be in their house and their dogs and their kids and all that stuff. So they are a little kind of flag that helps us be aware of the things that you cannot see that have long-lasting impact. There's some other cool things out there. When I'm thinking about the high-performance house and I'm sort of thinking about why do I want to build an envelope that's like a thermos? If I want that thing to use as little resources as possible, I need that thing to be efficient, because if we're electrifying everything, it makes it a lot more likely that we can get electricity from the sun and the wind. Mm-hmm. And the more that we are using renewables on our building, the more efficient that building has to be, right? Because the building is controlling the thermal loss, and the thermal change in that temperature is being generated by some gizmo, a heat pump that's using electricity. So we want that thing to efficiently use the power that we're getting from the sun or the wind or both.
Mm-hmm.
And so there are some neat things out there that we've been experimenting with, an experimental building we've been doing with the Advanced Energy Studies program at the university for the last couple of years. And it also applies to other homes where we're making changes in relationship to the efficiency. And as more and more people want to transition to some amount of their energy coming from directly from renewable resources. And so one of the things we've seen change a lot is the efficiency of battery storage.
Mm-hmm.
And as that grows in efficiency and the price comes down and the volume of storage necessary to power a house starts getting smaller and smaller and smaller. Not that that doesn't have a global cost, mind you, because we got to get the materials from somewhere.
Yeah.
Dang it. But there are some really interesting new technologies when it comes to that sort of technology in terms of generating power and storing power and monitoring our use. Because here's the other thing about a high performance house. Most high performance houses are very expensive.
Mm-hmm.
They're expensive components and they're complicated to build. Even if they're just like a box, like a shoebox, they're still complicated. And so what we find is we're tending to build smaller and smaller of those, and then enter the whole tiny house realm, right? Really tiny house. It's really easy to make it uber efficient, right? But it doesn't look like other houses. And if we continue to use, we expect from solar energy and battery storage and high efficiency appliances, I still don't think it's in alignment if we expect that house to perform like the house we grew up in as a kid. And so there's some measure of behavioral change that has to happen if you want to live in a high performance house, which for most of us and most of our clients, that means that the house goes from this big to that big.
Not that you have to do a tiny house. Okay, let's
No,
get straight, because you cannot fit your Amazon boxes in the tiny house.
I have so many Amazon boxes.
Oh,
But then I use them.
You.
I use them as exterior insulation. I just staple them right over there, and it's like immediate. Like I have so many Amazon boxes that I could clad your entire house, which is what they used to do with newspapers a long time ago.
So ridiculous.
I guess there's a lot of interesting technologies, and those technologies have to go hand in hand with the building. And I think really that if we're going to live in a smaller building that costs more per square foot, which is what most of our clients have to do, they have to make decisions. It's very difficult to build a 5,000 square foot passive house. It's incredibly expensive, right? Let alone an apartment block, which is being done, but huge expense. And so one of the things that we're doing is that we're making these buildings smaller because of the cost to build these buildings. And when this buildings get smaller, the expectation of the occupants have to change.
Yeah.
The way that building is used and our behavior about using the resources to power that house, they have to change.
Mm-hmm.
And we have done a lot of experimentation individually and as a company with really small, really well-designed, small spaces.
Mm-hmm.
They require more expense from a design perspective too, because the design has to be really well thought out to live in a space that is half the volume of what you might be used to or what we might be used to.
You know what? I'm going to say something too that's really
I hope it's controversial.
It is controversial. And it is that, and it has to do with the small spaces, and I'll give a shout out to the Orderly Place, which is an organizing company that will come in and help you organize all your stuff.
Yep.
And I will say that I don't want people to feel like I'm going to judge them when I walk in their house.
Harshly.
So I'm not.
Too.
I'm not. I know. I mean, if you walked in my house right now, you'd be like, you need
You
to
would be
organize
horrified.
this place. No, you wouldn't be horrified, but you'd be like, you need to do some organization. But the reality is, with a smaller house, it is a mindset. I mean, there was a great series of books that came out by Susan Sazaka, I think her name was, and she had the Not So Big House. Yeah. And that was sort of for me, that was sort of the beginning, the introduction to that whole mindset. And it's more of a simplifying your living, how much is really enough. All of that really, to me, that really goes hand in hand with high performance building, is how much is enough.
Yeah.
And you just need to, at some point, just say, I've got enough. And stop.
And live in a van like me for 3 years. It's a really small space. It's super efficient, and it costs nothing to operate except the gas.
Yeah.
Not that we're suggesting that, but we do have a pretty sweet tiny house in our backyard that you should come check out sometime, because it's been pretty fun to build, and it's pretty neat as an example of a different way to think about a building.
But all of this practice has helped us when people come to us for an ADU, an accessory dwelling unit, that's going to be smaller than their main house, and is for a relative, or they want to rent it out or whatever. We have a lot of practice at at doing small buildings and helping people organize. And
how do you get 2 bathrooms out of 1 bathroom in a 1915 Victorian?